Okay, good evening, everyone. It's a pleasure having you all here with us. And today is our new webinar, and it's a series of webinars that the Spatial Analysis and Simulation Lab community, SASL, is just started to establish from last October. So this is our website. This is what we do actually. We dealing with things related to trying to understand the spatial configuration analysis, and we're trying to understand how people navigate through urban spaces, open spaces, and even intermediate spaces between the buildings and outside issues. We do have a series of research related to space centrics, to photogrammetry. We are having all those our section of simulation methods. We do have our own tool called HAYES. It's like a replica of space centrics with special functions, and it's open source. Everyone can use if you wish. We do some automation as well, and we're dealing with things related to GIS and try to capture movement analysis, movements from videos and capture them toward GIS in real locations. And we're going to publish it very soon and going to be open source, whoever would like to consider. And let me move to our today's webinar actually. So today we have really a distinguished guest speaker, Professor Matias del Campo, and I hope that I've pronounced the name correctly. Yes, thank you.
Perfect.
Thank you. He's an architect and AI expert, associate professor of architecture, New York Institute of Technology. He's the director of Master of Science in Computational Design, co-director of AR Squared Laboratory, University of Michigan. And today's webinar actually is going to be a little bit different from our previous webinars. It's really going to be an interesting one because we're going to introduce an AI tool. So with this webinar explores the transformation impact of artificial intelligence AI on architectural practice, theory, and how through a lens of latent space navigation and generative AI methodologies. Architect and theorist Matias del Campo will dive into how contemporary AI technologies such as generative AI or GANs, diffusion models, advanced computational design tools are redefining architectural aesthetics, representations, and tectonics. We are so happy that you are here with us, and I believe that this is going to be a very interesting and important webinar. Thank you for joining us, and the floor is yours.
It's my pleasure. It's my pleasure. Absolutely. I'm going to start sharing my screen. Yes, thank you very much for the generous introduction. So just briefly to recapitulate, my name is Matias del Campo. I'm an associate professor of architecture at the School of Architecture and Design at the New York Institute of Technology, where I'm also the director of the thesis MSACT, the Master of Science in Architecture and Computational Technologies. And I'm also the co-founder with Sandra Manninger of the ARIA Laboratory, which is an interdisciplinary laboratory between architects, computer scientists, roboticists, data scientists to explore the opportunities and chances and the incredible ways they can go forward in using artificial intelligence in architecture. I would like to sincerely say thank you to Dr. Nabil Mohareb for having me tonight to speak to you at the SASL webinar. And of course, speaking in front of the distinguished students and colleagues of the AOC. It's a true honor. It's a true honor. So today we're going to, the lecture is called Tectonics of the Latent Space, and I'm going to try to break down some of the ideas, concepts, and theoretical aspects of artificial intelligence in architecture, what they mean to us. But first and foremost, at the very beginning, we have to ask them like the very basic question, which is what is AI, generally speaking? I have the feeling there's a lot of confusion out there of what that actually means, what it is, what it can do, and what it cannot do. So if you think about it, there's like a whole plethora of different algorithms, ideas, concepts, theories around artificial intelligence. Basically, what you have to say, it is an umbrella term. It's a term under there are a lot of different aspects coming together. They all put together to describe something that could be seen as artificial intelligence, but there is no one artificial intelligence. It's a whole variety of things that come from machine learning, natural language processing, speech processing, and vision processing. Already in 2015, Pedro Domingos identified 5 different tribes that you can describe within this universe of artificial intelligence. They consist of the symbolism, connectionists, evolutionary algorithms, Bayesian algorithms, analogizers, and ideas on connectionism. All of them, again, subsumized under the term artificial intelligence. The most visible one these days is probably connectionism. You probably encounter connectionism algorithms every day, constantly, when you're like going on in your day-to-day business. You open Amazon, you will be facing some AI algorithms. You play around in Instagram, social media, banking, like all traffic, cars. So all of the things that are already surrounding you are deeply entangled already with artificial intelligence, facial recognition. For example, there's a lot of algorithms now that decide whether you get a loan in the bank or not. So it's basically all around us already. It's not science fiction, it's part of our reality. So there's, of course, the other like big aspect of it, which is the impact of artificial intelligence on human culture, generally speaking. So we have seen in the last 6 to 7 years, like a huge leap forward in the ways of using artificial intelligence, not only in pragmatic and practical terms, but also as an artistic technique, whether this is in the visual arts, in poetry, in music, in fashion, in literature. Yeah. So it has become absolutely part of the cultural production of humanity. And there's, of course, a lot of questions that come along with it, which is, what about human agency, talent, sensibility, of course, also authorship. And this has been like an ongoing debate now. I want to add to this, though, that every time a new computational technology comes along, there's almost the same debates. It's like is this who's the author of something that is generated automatically in some way, shape, or form? It's not the first time that we encounter generative algorithms. We have seen that from the 90s onwards, yeah. And similar debates have been also happening in the past. However, what I'm really surprised about here is the depth of this cultural imprint, because if you think about it, like these architectural methods that we have been seeing throughout the last 30 years were basically contained to architectural conversations, whether this is polygon modeling, NURBS modeling, parametricism. All of those things were primarily discussions that happen in architecture. Artificial intelligence is a different animal because it's an open system, meaning that it opens up the possibilities that we have in architects, and the discussion is not contained in architectural circles. They are actually entangled in every other aspect of cultural production. So how does AI affect more specifically architecture? So what you see here is a diagram or a statistic that was done by Goldman Sachs in March 2023 that named like a whole series of different disciplines and the way how they will be affected by artificial intelligence in the next 10 years. What you see here in red is architecture. So this means that you see the percentage of how much it will be affected. Architecture will be affected 37% which means basically that every third job in architecture will change because of artificial intelligence. This does not mean the job goes away. Please don't misunderstand that. It just means it will change the job we do. Similarly, also to the digital revolution of the 90s, where like a whole variety of different new tools changed the way we do architecture. It might be indeed accelerated through this new technology. So if this is all true, if this new technology is changing architecture so much, we have to ask a couple of questions. So how can we shape the discourse of architecture? What does it mean for us as somebody who contributes to culture? I have done in the last couple of years, together with friends and colleagues, a series of symposia, events, exhibitions, publications, meetings in order to understand what does it mean for architecture? How can we contribute to this new upcoming cultural universe that we see emerging here? What does it mean for our own presentation and representation of the world, with all its good and bad parts? Yeah. For this, we did things like, for example, the Neural Architectures Exhibition and Symposium, November 2022, which happened at Taubman College. And also at Taubman College, the Data Justice, AI, and Design Colloquium, which dealt more specifically with the ethical and the biases and the darker side of AI, so to speak. Like, how do you deal with it? How can you make people aware that when they're using this kind of tool sets, it's not just something that comes out of the cloud, out of nothing. There's something that it's based on. There's things and productions and art that are included in the data sets. And there's, of course, cultural, ethical, racial, and gender biases in those data sets. So we tried to somehow immediately go into the public and try to somehow explain or try to create a basis for an architectural discussion that is based on what this technology can and cannot do. All this being said, I'm completely convinced that this is the first genuinely 21st century design method. Going back maybe a little bit to what I mentioned before about the development of computational tools in the 90s, things like polygon modeling, NURBS modeling, agent-based modeling, scripting, like all of those things were basically already, parametric modeling was basically already present in the 90s. What we've been doing in architecture for the last 25 years is improving those methods, improving these techniques, improving the technology, but it was not truly something that emerged genuinely in the 21st century. This year is not different. AI is something different. What we see happening today, and all of you have seen it, was not possible even like 6-7 years ago. The improvement of technology with better GPUs, with larger data sets, has actually is feeding into this new development and making those things visible that you're seeing today. So neural architecture is a new paradigm, not only intellectually and culturally, but also technically. What we see today was not even possible a decade ago. So into more detail, like how does AI impact the AEC industry, architecture, engineering, and construction? Imagine the life cycle of a building. And we're dividing this into 6 parts. And traditionally speaking, you have things like preliminary design, the design phase, the planning phase when you're getting closer to construction. Then you have the construction phase. You have the maintenance of the building during its lifetime. And then at the end, you have the demolition. So that would be like the whole life cycle of a building, conventionally speaking. We're seeing already how this is changing through AI. People are prompting now instead of sketching on a piece of paper. They're doing fast iterations in the design process through the use of diffusion models. They use generative planning tools that use things like pix-to-pix and other methods. You can use, for example, machine vision on construction sites to make them safer. You can use machine vision and augmented reality to inform people of things to do during the life cycle of the building to maintain it. And at the end, you can again use things like machine vision and robotics to disassemble the building and reuse as much material as possible. So you see basically all of the things. This is not science fiction. These are all things that can happen already today. And at this line shows like a whole different set of algorithms or models that are already available that can do these kind of things. The vast majority of the public, in terms of architects and students, only see these first 2 boxes. And this is where I think we need to do more work as architects, like really try to emphasize that there is a much bigger universe of things that we can do with AI than just what we see so far. Another really important aspect for me is that if we do not engage with AI as architects, someone else will do it for us. Meaning that investors, construction companies, developers, they will actually just use those tools to do their planning without architects if we do not really engage with it immediately and with full force and actually claim the intellectual, discursive, technical aspects of it for us and make sure that the expertise is with us. So why do we need to demystify artificial intelligence in architecture? Consider it like an iceberg. Right now, the public and most architects see things like ChatGPT, Midjourney, DALL-E, Stable Diffusion, BART, and other off-the-shelf available algorithms or websites, basically. Most of them are closed. You cannot change anything. You cannot change the weights. You cannot change like how the algorithm works. You cannot change the data set, right? But underneath the water surface is the vast larger part of the iceberg with a plethora of different algorithms that can be profoundly useful for architectural design, yeah? Tree GANs, nerves, energy-based models, graph CNNs, variational autoencoders, YOLO, etc., etc. There's like a lot. And there's much more by now than when I did this graphic, because this graphic is like 2 years old, and you can add even more to them now. And at the very bottom of it is the data sets. That's everything, like without the data sets, without the data, nothing works. So we have to be aware that the collection of data and the curating of data sets is something that we as architects might need to understand and like really do in order to create bespoke solutions for problems that we encounter while we're planning architecture. Let's go into the latent space. So the whole lecture is called Tectonics of the Latent Space. What do I mean by that? There's aspects like estrangement in inference. This is a video that I did. Wait, sorry. Did you see the video? No. Let me go back one more time. What's going on here? Okay, so this video is basically a latent walk through a data set of Austrian architecture. So I collected thousands of images of Austrian buildings and then basically tried to find like what's the essence, what's the main motif, what's the main features that makes this architecture Austrian, so to speak. And I intentionally also like sort of trains the model not to be perfectly precise. So it was not supposed to give me like a perfect design or a perfect building or something that looks like a realistic building. It was supposed to hallucinate. So you can basically use these machines against the grain, so to speak. You can, of course, train them to give you something that looks like a photorealistic image of some building that's standing somewhere in your country, but that was not what I was looking for here. I was looking for the dark corners of the latent space. I will go into a little bit more detail what that means. But for now, let me explain to you that what you see as a latent walk is basically a sort of curve fitting within all the data points that you collected, in this case, thousands of Austrian houses. And depending on how that curve is going through that space, how close it comes to certain data points, it will give you something that looks more realistic or more unrealistic. And you can basically, through the weights in the algorithm, push it in which direction it's going. Is it more realistic, or is it something that is more imaginative, surreal, strange, and so on? I like to look into these stranger places because these are the spots, I think, where you can find things that are different, surprising, beautiful, useful sometimes, but always kind of provocative. So they will, in a way, provoke you as the human to do something that is different to what you normally would do as a designer, maybe. And this, in my opinion, represents a form of progress in terms of what you can design. It's really like an extension of your mind. I do not see AI as a replacement of human intelligence. I see it more as an extension that helps you create some things that are different, interesting, and exciting. Just very quickly, a quick explanation of how diffusion models work. I know every one of you have been working with things like Midjourney, DALL-E, or things like that. It's quite an interesting technique. You basically need a lot of data to make it work. So one of the data sets that is used in this diffusion models is called the Lion 5B, which is a data set housed in Germany and has over 5 billion annotated images. And what it does, these diffusion models, they basically start to add noise to these images. So they add noise until it's random noise. And then according to your prompt and following something called a Markov chain, it starts to denoise those images towards the prompt that you gave it. So it's basically organizing pixels in a way, or sorting pixels. Yeah, that's what you see here, right? You have the data, it starts to give it noise, and then it turns around the whole process and denoises it until you have an image. So basically it does something like this. right? So in a way, the interesting thing is that we are not abandoning a formal language. It's a reconfiguration of it. Yeah. So columns fragments into apertures, ornament becomes mass, structure and texture collapse into visual fields of almost architecture. This is not simply form making, it's a recalibration of architectural imagination. I briefly talked before about the latent space. This is an image that basically represents one layer in the latent space. You see it's a three-dimensional cube. By the way, in this sort of space, there's like endless amounts of dimensions. This is like a mathematical thing, which is quite exciting and strange and wonderful. And this curved surface that you see going through it is this approximation to a certain group of data points that will give you a certain design or result or image, if you want. Yeah. What you have to know also is that AI, generally speaking, I think that it cannot generate genuinely something new. I mean, we could discuss about the term new now for the rest of this lecture, but it can, in my opinion, it cannot do that because it's based on existing data, and it can only interpolate between existing data points. So it cannot really come up with a new idea, so to speak, but it can find things that we did not see before. So in a way, AI is more like a telescope or a microscope that let us see things that we could not see before, but they were there. Like we can see in a telescope the craters on the moon, since we have a telescope, but they were always there, or well, at least some of them. Okay, let's keep on going. Defamiliarization is a method. So defamiliarization is a concept that basically comes from people like Victor Shklovsky, who wrote a paper in 1917 called Ostranenie or Estrangement as Artistic Method, I think it was called. And the idea behind it was to create something that is familiar enough for you to recognize as a spectator who looks at art, but strange enough to evoke your attention. And this whole concept of attention is something that in AI is really a very crucial concept. And I think that we can basically make use of it as a form of design method if we intentionally embrace it. In these two videos here, for example, you can see on the left side a data set which was brutalist buildings. So I made like a whole collection of brutalism designs. And in a way, you can recognize it as some form of brutalist design. Yeah. What you see on the right side is the same data set, but in order to somehow confuse the AI a little bit and get something more strange out of it, I threw in a couple of Picasso paintings. Once you know it's Picasso paintings, you're going to start seeing them, by the way. You probably didn't see them before. Yeah. So this idea to somehow like, again, using the machine against the grain or throwing off the computer, throwing off the AI from its course, I think this is the method where you get probably the most interesting, exciting, and innovative solutions out of it. And of course, on top of it, it needs your human imagination and your human intuition to see that this is something interesting. For a machine, most of the time there's always just wrong and right. So for a machine, the images on the right probably would be wrong, and the images to the left would be right because they look like buildings. Yeah. But the human imagination tells me that those images, those Picasso strange images, maybe I can do something with that. Maybe I can color a building like that. Maybe I can continue designing on that line. Let me talk about something different that has to do with bias into data sets, because this is an important issue when we're talking about these things, generally speaking. What you see here is a diagram that shows the amount of images annotated by different countries and different cultures, of course. So you can see that the vast majority of imagery used to train diffusion models comes from the United States. The vast majority, meaning that every other culture around the world, when they're using any kind of AI system, will rely primarily on American data. It will not represent their own culture. And I have had some really interesting thesis projects before that were trying to explore that problem. I had one thesis student from Morocco, no, from Algeria, who basically wanted to figure out, can she somehow generate Algerian architecture that somehow abides to their cultural background? So she had to do her own data set, and she found out one of the problems with doing that is there's just not enough data. Yeah. So it's very hard to come by this. And then on the other hand, what do you do with cultures that do not primarily use visual data, right? What do you do with cultures that, I don't know, rely on music or dance, motion, things like that? Yeah. So we're still at the beginning of understanding how we can do this in the best way. Like, how can we create a data set that is a little bit more diverse? Yeah. We tried to do this in several times already with the lab. And we made calls international about people annotating imagery and stuff like that. And still, at the end, when we analyze our results, we still figure out that most of the data still comes from the United States, UK, a little bit of Europe, and a lot from China. So we probably need to find another way of how to somehow create data sets that work a little bit more in a more diverse way. I just briefly want to mention this book here. If you're interested in the topic, please, this is a good read, Atlas of AI by Kate Crawford. Okay. Let's continue with another aspect here. So this is just an image about the training of a data set we did of mid-century modern designs in order to be able to navigate that space. You see again here some results from these early examples of latent walks. I'm a big fan of style GAN still, because it provides such interesting results. And that allows us to do things that are in 3D, but also like these very strange Piranesi variations, I would call them. By the way, these are currently on show in the Maxi in Rome, these Piranesi variations. And like all this being said, this is something where we need to understand that that's where we're going to go with the designs further on, right? It's not a passive condition. It demands a new kind of intelligence, one that understands the logic of pattern recognition, that can read noise, refine unexpected output, interpret spatial data without fixed typologies. Generative models do not produce plans or sections in the traditional sense. They offer fragments, fields, probabilities. The outputs do not cohere immediately. They must be curated, filtered, teased into coherence. This is the design as translation, not execution. The architect becomes a mediator between machine-driven perception and formal plausibility. They work not with lines, but with relationships, not with rules, but with thresholds, intervening in the middle of processes, guiding the model, seeding the prompt, polluting the dataset. The act of drawing is replaced by the act of conditioning. The shift from design decision to training is profound. It redefines what it means to design. It expands the field of authorship to include the dataset, the model architecture, the feedback loop. Every iteration becomes a negotiation. Architecture is no longer composed. It's extracted from noise, not dictated, but uncovered. The future design is not a stylist, but a cognitive interlocutor, a translator of machine learning's latent, unexpected outputs into meaningful spatial possibility. And so the task of the architect expands, not to perform form, but to expand the possibility of space, to construct new conditions of emergence, to transform AI from a tool of repetition into a site of archaeological imagination. Thank you very much.
Thank you very much for this valuable, informative presentation. It's really, really needed, and I cannot express my gratitude for being here with us today. Thank you. So we're going to open the floor for questions, and I may take the privilege of the first question. if I may, until everyone else will just write their questions in the Q&A, or if you wish, just raise your hand and we're going to start dealing with the question. Well, this is like reminds me with the first time the calculator appears, or the first time AutoCAD appears, or the first time BIM appears, which is like always a negotiation between should the students use them, architecture students should not. If it's something authentic, it's not. And always we came to into conclusion, yes, it should be integrated into the education at a certain point. So from your point of view, how we should integrate AI effectively, not just passively. I mean, every student they are using Midjourney, they are using right now, even ChatGPT, the image generations is being improved more than DALL-E 3. Leonardo, or whatever the AI tool that they are using. And some of them even use them to generate 3D, like for the interior design, from text to 3D, text to videos. So how to move from a passive using AI in education to some sort of an active, or maybe change our mindset in teaching architecture? I would like to hear your point of view about this point.
This is a very good question. Thank you very much. And yes, I've been trying to figure out how to move ahead with this, because on the one side, the omnipresent of online tools that are off the shelf for everybody to use, it's very seductive to do that, like to use all these online tools that are available right now. The problem is that they only provide like a small segment of what we actually need in architecture, right? If people use image generators for ideation at the beginning of a project, I think that is good. That can help a lot of students, because many students still have this sort of anxiety, like this fear of the white page. They don't know what to sketch on it. So something that allows them to somehow use their language, like natural language prompting, is certainly something that helps a lot to overcome a certain amount of anxiety towards, like at the beginning of a design, at least. But then that's when things become interesting, because what do you do beyond that? Like, what do you do beyond using, an image generator or a large language model to write your essay, right? What I notice is that even using these sort of tools, you still need like an enormous amount of knowledge about the architectural history, art history, design, any form of culture, even music, if you want, or whatever it is, in order to be able to create a prompt that will do something that is interesting, or at least in some way useful as an architectural design. Because what we don't want is a mediocre design at the end, right? And if people do not put their fantasy, their imagination, their knowledge, their background into a prompt, then that's exactly what they're gonna get. They're gonna get just like the baseline of that, what AI can do. They're not gonna go beyond that. So the second step, I think, is like, okay, they can start with that as an ideation tool, but then the next step is really, okay, how can I get deeper into that? How can I somehow create a model that will sort of like a custom-made model that will help me continue the path of that design, so that it doesn't fall into something, mediocre or boring or repetitive, right? The chances are high that if you are not that good in prompting, you probably get something out of that AI model that already exists. So it's gonna overfit. Sorry, it's gonna overfit a lot. Yeah. So for education, I think it means, on the one side, the education that we get now as architects in terms of learning the history, learning what is a Baroque church, what's a Gothic church, and so on, will still be useful, because that's how we can explain to a machine what we want to do. Yeah. I think you should treat the AI more like a collaborator and less like a slave. Yeah.
Yeah, I totally agree. I think there's a question from Randa. Yes, Randa, if you'd like to say a question.
Thank you so much, Professor Matias, for this outstanding presentation. It was very informative and insightful. Thank you so much. I have one question. Can latent space exploration be tuned to reflect local climate or urban morphologies, especially in terms of climate change issues?
Great Great question. That's a really good question. Thank you very much, Dr. Randa Khalil. Maybe to give you something ahead of the answer. Anything that can produce numbers can be used in artificial intelligence. So any statistic, any mathematical formula, specifically if you have collections, like for example, Excel sheets of climate change data, yeah, that is like ideal for an application in AI. Yes, so you can basically, for example, create an AI model that is completely working on the local scale for your design, for example, but taking into account global climatic developments. Yeah. And you can then like this. Another thing I want to say, AI can do two things really, really well. One is optimization, and the other one is prediction. This is basically all that AI does. So considering your question, provided you have enough data about climate change, local climate conditions, and so on, of the last, let's say, 100 years, you can absolutely optimize towards the climate impact of your building. Yes.
Thank you so much. Thank you. I think I have another question. May I ask it?
Yes, please.
Okay. What are the ethical implications of latent space manipulation when it comes to design identity and ownership?
Yeah, that's a very good question too. So, I mean, this is a whole book, I have to say. It's a really good question.
Yes.
I'm not sure I can fairly answer that right now, but I can say that I'm happy that people are thinking about that. Like, what's the ethical implications of using this technology, a technology they can learn, and that a lot of companies are using data of questionable sourcing, I have to say. So I think what you need to be aware first is that it all starts with the data. Like, how is the data collected? Where does it come from? Who annotates it? Who selects which image, which kind of data gets into the data set in the first place? So all of these are ethical questions, yeah? Ethical decisions, right? How culturally diverse is the data set? Or do you want to make a data set that is specifically only addressing one culture for a certain reason? Yeah. Do you really include everything in the data set, or do you think that it might just confuse your AI model if you add all of this? There are several books out there that discuss this issue that I can highly recommend. Like one I mentioned already in the lecture, which is Kate Crawford's Atlas of AI. But there's another one by Ruha Benjamin. It's called Race After Technology. Yeah. That's a very interesting book when it comes to racial bias, for example, in technology generally, but also specifically in AI. So, or for example, Joy Bulavimi, Unmasking AI, is also an interesting book. Joy Bulavimi became famous with an experiment that she did a couple of years ago, which was about facial recognition, where she actually figured out that a lot of facial recognition software has problems recognizing people of color because there were not enough people of color in the data sets. Yeah. So,
Yes.
so there's a lot of discussion around the topic all around the world, and I think it's just going to become more if people just become more aware of the problem. Yes.
Yes, thank you. Thank you for suggesting these two books. It would be interesting to read them. Thank you so much.
Thank you. I think there is a question from the chat box, and then we're going to Mariam, and then go to Dr. Matias. So from the chat box, Dylan, I think the question is, I wish I could open my mic. So okay, let's go to the question. My question is about the challenges in defining tectonics in a very abstract, reduced space, latent space, where tectonics is mainly about dimensions.
Thank you. Thank you. Another really smart question. So this is a good one because I'm not entirely sure I can answer that either. I know that, for example, when I started to discuss the idea of the tectonics of the latent space, it was basically, if you think, for example, about Kenneth Frampton's book on tectonics, his book is profoundly material, right? It's like this the layering of material, the way how it is, how you construct something, the method of construction, like all of this is basically like so core architecture, right? It's like the core part of our discipline is this idea of putting elements together that as an entirety create a tectonic of that building, right? Like tectonic layering, right? I was thinking in the idea of the tectonics of the latent space about the way how within that latent space these data points are basically continuously creating a construction too. They're constructing a form of reality that we experience then as images or 3D models or whatever it's outputting. Yes, it is digital. It's not material, like in Kenneth Fremd's example, but it's in a way also about construction. It might be rather like an intellectual construction and less a material construction, but it's still a construction, right? And this is basically how I'm reading the tectonic in that space. So I'm not talking about physical material stone on stone construction, but another different form of construction that is more digitally, it's based on information, it's based on algorithms, etc. But still, in the same vein, a form of construction. And because we as architecture discipline have this long history of discussing tectonics, I thought it's a good way to explain to architects why this whole AI thing is such a profoundly architectural problem. Does that make sense?
Yeah, a lot. And I hope that Gina is hearing us. So let's move to the next question, Mariam, if you wish.
Yes, thank you for the super interesting talk. You've also shared fascinating examples of AI in design. So in your opinion, what are the most urgent or unexplored research areas for hybrid methodologies like these that maybe combine traditional design intelligence with the generative AI systems? Where should young researchers focus their energy on?
That's also good. I mentioned before that AI can do two things really well, optimization and prediction. And basically also there's two areas that you can explore with AI. One is like the wicked and the tame problem. Are you aware of what that means? Wicked and tame problem?
No, not really.
No, for
Okay.
me, no. I'm sorry.
Okay, so the wicked and the tame problem are two terms that come actually from engineering. And they basically describe the tame problem are all things that are measurable. Like, for example, you know exactly the size of a screw that you're going to use in a building, you know, the width of a door, the height of a door, the dimensions of the room, the height of the glazing you're using. So these are all tamed problems. We can solve them in engineering rather easily, right? We know, like, if I do a window this size, I'd rather use maybe a thickness this thick so that it doesn't break too easily with wind pressure, for example, right? So these are engineering problems. The wicked problems are the ones that are not easy measurable, like the atmosphere in a room, the sensibility of the material, the sensibility of the coloration, things that have to do with aesthetics. Yeah. So these are the two areas that, again, wicked and tame problem. And with AI, it's very similar. You can use AI very pragmatically just to optimize, for example, the structural engineering of a building, the material consumption, the energy consumption of a building, right? So these are like tame problems you can solve with AI. And then there's the wicked problems that you're trying to solve with artificial intelligence. Okay, how can I express our contemporary age through a specific aesthetic that is derived from artificial intelligence, for example? Is that possible? Or is there still a lot of my own mind in that solution? Yeah. So what I'm trying to say here, if you are a young researcher, you have to decide which one of those you want to tackle. Do you want to tackle a tame problem and say, like, I want to use artificial intelligence to optimize the material consumption in a building to make it more, you know, sustainable? Or am I interested in finding a way to express our time through an artistic technique that will do an aesthetic that no one knows yet? So these are two, maybe you can combine them. Maybe one works with the other. I can only tell you, there's like a whole universe of possible things to research right now with AI, because you can question every single aspect of architecture. You can focus, for example, on, let's say, building maintenance using artificial intelligence over the next 30 years, using prediction models. No one has done that in a proper, larger way yet. That would be an interesting one. Or for example, in the planning phase, how does, for example, how can you optimize your building plans to work better with local code? Yeah. So I think that just choose one interesting area in architecture that's interesting for you, and the scale doesn't matter. It can be from one family housing project to city scale, yeah, or even country scale, or planet scale, right? Just choose something that you think is interesting for you, and then just, put your energy in there. Does it make sense, Miriam?
Yes, thank you so much. I'm currently pursuing my master's degree in architecture, focusing on augmenting architecture education through AI, and I will be conducting interviews with leading voices in the field and would be honored if you would be open for a short interview.
Sure, absolutely. Absolutely, yes.
Thank you so much.
Thank you. Thank you very much. So we have Dr. Matias, if you wish.
Oh, thank you very much, Dr. Nabil, and thank you, Matias, for this great presentation. I just wanted to take the question of Dr. Nabil, the first question, a little bit further in terms of, because I'm very much interested in the curriculum development and pedagogical issues. You were talking about the need to write proper prompt and then creating some sort of models, and this would lead us to some sort of optimization and prediction. And my worry is that, about the current practice of providing programs and currently in architecture, design, and technology. Do you think that this would create some sort of dependency on the technology, and we are losing loads of the skills which we currently have? And also, this would raise another issue for the current programs in terms of the assessment and evaluation, and how we are going to really look at the quality of the production or the process itself, and to what sort of, the level of experience which we have to have as a teachers or professors in order to really deliver these kind of courses. So I'm slightly worried about this kind of a changing phase which we have at the moment. So how we should, or how do you think we should really work in order to overcome this kind of gap in knowledge between what we had and what we are going to have very soon? And there's another issue, or there's another concern I have personally about the speed of a change, because today we have generative AI, and tomorrow we have different levels of technology which would allow us to do something different, and the capacity of our programs to really cope with these kind of changes. So what we are supposed to do from your point of view? Thanks.
Yeah. That's a really good thing. I appreciate this question a lot, Dr. Matias. I mean, the more I think about it, the more I think we don't have to change that much. Because so core knowledge of architecture, let's say there's two main areas, okay? The one that is closer to the humanities and the one that is closer to the technologies. In terms of what we do in the humanities is, we know about history, we know about art history, we know about philosophy, we know about the design of even font design. Like, I remember I had to study font design when I was in school, in the university. So I think that specifically this knowledge about art history, architecture history, and so on, a certain amount of philosophy, a certain amount of psychology, is really important for us to maintain as something that is a core part of our discipline as architects. Because the one thing that makes architects so different to many other disciplines is we are amazing in synthesizing, like taking things from everywhere and somehow put that together to become a project. Whether this project is a building or the design of a shoe is a different story. But we're good in taking all these sort of different cultural influences that we experience as students, as architects. We literally, which other discipline plans their holidays around which building they can visit in summer and check out? I mean, no one does that. No other discipline does this kind of weird things. This curiosity, this profoundly human curiosity, is what we need to foster with our education in architecture. Because this curiosity is what makes them also better designers, even when they're using another technology like AI. And by the way, I'm not evangelic about this. I'm not trying to convince people to use AI. That's not what I'm doing. I just see that there is something happening right now, technologically wise, that will impact our discipline, and I want to talk about it. That's all it is. So I'm not evangelical. I'm not trying to convince anyone to use it. But one thing I can tell you, which I think is important in terms of education, is to create like a core understanding of what the discipline is before they even touch a computer, honestly. Like understanding that there's line weights in a plan, that there's sketching tools they can use, that there's basically ways of building a model, that there's ways to understanding history, and so on and so on. So these sort of core elements of the education will be the same. They will not change a lot. We're just using another technology now. And if you were talking about the progress of things, like imagine that. How many years have we working now with 3D modeling? 35 years? 40 years? I would say like 30 years within the discipline where we were really using it in schools. That's nothing in comparison to the history of architecture. Yeah. And by the way, there's this perceived speed of things, of change. This is also not entirely right. There's two different speeds at the moment going on with AI. One, the one that we see in the public, in the newspapers, on TV, it looks like they're like creating every other day a fantastic new AI model. These are all the same models. They're all just using diffusion models in a variety of different ways. They're trained differently a little bit, maybe. Maybe they're using a different data set, but they're the same. Yeah. Large language models is a different story. Those are really impressive. But I would not be. So I said like this is one speed, and that speed is that fast because millions and millions of dollars go into that research and into these companies. On the other hand, we have like the other AI research, which is like talking about convolutional neural networks and generative adversarial networks, like all these sort of things. It's much, much slower because it's not so sexy. There's not so much money in there. Yeah. But these are the ones that are really interesting for architecture. So these models, despite the fact that they're like 10 years, 20 years old, are still extremely useful for architecture. I would not just abandon them because there is a new diffusion model that works with transformers. It's not going to do the same thing. So I think I'm digressing a lot here. I'm sorry for that. Yeah. So I think I went completely different way. You were asking about education, basically. And in education, I can tell you that you have to do like you have to have a double strategy. On the one side, there is like the core understanding of what the discipline provides intellectually, technically, like also in terms of artistic techniques you can use. And on the other side, you have the technology-driven part, which is about using computational tools, AI, etc., etc. When you are able to combine these two successfully, then I think that's an interesting education. I don't think either too much of this or too much of that is the right thing to do.
Yeah, my point is that we need to shift from the existing situation in order to create this kind of merge between the artistic and technology, and to keep up with the technological changes as well within so this kind of flexibility within the curriculum itself is really a huge issue or challenge for most of the universities worldwide. This is my worry. Yeah, thank you.
I understand.
Thanks.
Okay. Thank you very much. And I think there is another question from Heba, Dr. Heba Gabr. If you wish to say it, or should I read it for you? Heba, are you with us? Okay, she's discussing about or continuing the point about ethical issues should be considered when using AI to recreate or redesign historical buildings, maybe reuse them or adaptive reuse or something like that.
Recreate or redesign historic buildings. Do you mean like building a new building based on historical data, or do you mean to restore an old building or restore a historical building? It's two different things.
Yeah, Heba, are you with us? If you'd like to elaborate more. I think she's with us.
I don't think she's here anymore. It's not on the list.
So maybe, I mean, if you wish to pick one of them, you have said like two different scenarios. Maybe if we are going to redesign beside a historical building or using a data set of historical buildings in order to recreate something maybe imaginary based on them?
I mean, the thing is, if you're, let's say you're building a new building and it should look like a historic one, and you're using a historical data set to do that, I think that's totally fair to do, because at the end, one thing that a lot of people misunderstand is that AI doesn't copy anything. It's basically imitating something, right? So it's not going to look exactly like a historical building that exists. It's going to be a new building with historical features. So I think you can totally do that. I don't see a problem with that. The restoration of historical buildings based on machine learning, that's a little bit of a two-sided sword, because you have to make sure that it really fits the historical precedent. But on the other hand, you can also use the AI to optimize it towards that goal. You can optimize it towards creating something that is as close as possible to what was built there.
So
I'm sorry, I lose connection. I'm sorry.
no worries. No worries. Was this your
I
question?
I was asking about when we use AI in heritage conservation or reconstruction and building an old building, we have to put some ethical consideration. That's what I'm asking about.
Yeah, I was just trying to understand.
While using AI, or when we're using AI in rebuild or reconstruct an historical building, there is some we need to put some ethical consideration while doing that.
I have a question for you. Why do you think that? Why is it an ethical problem?
Because people can control the data we put, right? We can control what we put.
You can control what you use. If you build your own AI model, you can control which data you're using.
You will put the data, right?
Yes, you collect the data. You're responsible for the data. Yeah,
you're responsible on collecting the data. Gave it to the AI, right?
Well, let me put it this way. Let's make an example. Let's say we have a church or a mosque that was damaged by earthquake or war. Yeah, and this is a mosque that was built in the 13th century. Yeah. So if you're lucky, somebody already documented that mosque before it was damaged. Yeah. So that's already data you can use. And I don't see an ethical problem if it is data that was collected by somebody local who was even if it was not a local one. Let's assume, for example, some British architect in the 18th century or 19th century documented that mosque. Yeah. There's the data you need to do the reconstruction, right? So I don't think that's an ethical problem. The only ethical problem I would see is if somebody puts together a data set with thousands of mosques from all over the world, which have nothing to do with that local mosque you're trying to restore. Then you would get something that is not true to the historical truth of that building. So, but this is still your responsibility as the architect to make that decision. If I, for example, create an AI model that is supposed to restore or help restoring a destroyed mosque, I because I have awareness about how AI works, would make sure that the data is really the one I need for that specific project, for that specific mosque. But maybe somebody who doesn't know that would just make a scraping of the internet of every mosque he can find and then somehow put something together. That would be a problem.
Yeah,
does it make sense?
That's what I mean. Yes.
Yeah.
Yes, that's what I mean.
Yeah, but that's exactly why I'm why I'm really trying to make people understand how these things work so that these problems don't happen.
Thank you. Thank you very much.
Thank you.
And we have last question, Marwa, if you wish to address your question.
Thank you, Dr. Nabil, and thank you, Matias, for this interesting lecture. I want to ask to which level should the architect know about the AI in the term of programming or algorithm I mean, should the architect learn programming and know how to do everything, or we should collaborate with people from computer science department or programmer?
Thank you very much. I mentioned at the beginning that I have a laboratory that is a collaboration between architects, computer scientists, roboticists, and data scientists. And I can only encourage you to do that, like use interdisciplinary collaboration to do this kind of thing, because computer scientists are just so much better in programming than architects will ever be. Yeah, because it's not our profession. And it doesn't need to be our profession to be able to code. But we need to understand enough about coding and enough about programming so we can describe the problem to a computer scientist. It's similar, like for example, when you study architecture, you learn about structural engineering. Maybe you can even calculate a beam, a simple beam. Yeah. But just because you know enough about that doesn't mean that you become a structural engineer. You still have to go to a structural engineer and talk to him. Right? And I see this similarly with AI or programming. You have to know enough to be able to understand this part of the code is doing that, this part of the code is doing that, and then go to a programmer and talk to him. By the way, there's even a much better solution. There's a new term. It came up like spring this year called vibe coding. I don't know if you ever heard about that. Vibe coding, meaning that you basically describe what you want to solve and you write basically a prompt in a large language model and it will give you the code. And the surprising thing is it works. It works really well. Yeah. So I would say, no, you don't have to become a programmer. You don't have to become a coder, but you have to understand enough about it to be able to describe the problem.
Yes, thank you.
Thank you very much. Do you have the time to have one more question?
Yes, sure. Yes.
Isra, if you wish to address your question.
Well, thank you for this informative presentation and this insightful questions. I just want to ask about the multi-objective trade-offs between this aesthetic novelty and environmental performance. In parametric urbanism, we often optimize for things like solar exposure, thermal comfort, and urban heat island reduction. How might we balance those objectives against the strengths or novelty metrics you get from the Latent space exploration using a multi-objective optimization algorithm? We all dream of AI platform to save time and effort, scripting and thousands of iterations we make and to pick the optimal solution. So can we use this with a multi-objective evolutionary algorithm to get the optimal solutions directly to save time and effort?
I'll make it short. Yes.
Okay. What kind of AI platforms that we can use?
Well, you just mentioned it.
Okay, I mean, this takes a lot of time, effort, and knowledge. Can we, I mean, as a researcher, we can make it. I'm working on making students who use it. I have the time to teach them how to use Grasshopper for Rhino as an example. So I want something more faster or something like that.
Yeah, I mean, you just mentioned a multinodal evolutionary algorithm, right?
Yes.
And you basically can script that like pretty much in no time using a large language model today, and you just go into Google Colab and run it there. And you can chain even some of those together instead of just having one. Let's say you have like several different ecological impacts you want to explore: wind pressure, solar radiation, earthquake, whatever. I don't know, like precipitation, let's say. So you have like 4, and you can create basically 4 chained models, right? That basically can talk about all the things at the same time instead of having one by one. that would be like the more common way to do it. So, but the only thing you will have to have patience is you need to have a couple of really good GPUs on Google Colab to be able to do that in a certain amount of time, because of course you can create a super complex AI model that does all of this, yeah, but it will also need to be trained, it will also need to be run, and all of that means computer time, which means more GPUs, which means more costs. It becomes expensive.
Thank you very much, and thank you for all the participants. And please, I'm so sorry for anyone who addressed some questions that we didn't, mention them in our discussion. You can send them through LinkedIn to Matias, and I think maybe he might have the time to just reply or respond to them. It's a pleasure having you here. Thank you very much, and we hope to have future collaboration between your lab and our lab, if that's possible, of course. And it's a pleasure being here with you. Thank you.
Absolutely. Thank you very much. Thanks for the invitation. And I'm sorry I couldn't answer all the questions. Please send it to me. I hope to find time. Yeah. Okay. Bye, everybody. I have to run.
Bye.
Thank you.
Thank you. Thank you very much.